Hello and welcome to Chapter 9, Section 4, the tangent ratio. The essential question is, how is a right triangle used to find the tangent of an acute angle? Is there a unique right triangle that must be used? What you will learn is how to use the tangent ratio and how to solve real-life problems that are involving the tangent ratio. So what is a tangent ratio? It is a trigonomic ratio is a ratio of the lengths of two sides of a right triangle. Okay, so we're introducing this new thing that's called a trigonometric ratio. There are several trigonometric ratios. The one we're going to focus on here is the tangent one. So remember, a ratio is just basically a fraction with a number up top, number on the bottom. Okay, so a tangent ratio is the trigonometric ratio for the acute angles of a right triangle that involve the lengths of the legs of a right triangle. Okay, so all we're going to be using for this tangent ratio are the two legs. So if we look at this image here, all we're going to be using is that piece and this piece. Okay, and then the order is going to depend based on which of the two acute angles, A or B, that we are using to find the tangent. All right, so for example, what we're going to be doing is we're going to be finding the tangent of a certain angle. Let's say I want to find the tangent of angle A. So tangent of angle A would be its opposite side, which would be this leg over here. So there'd be opposite over the adjacent leg, which would be this bottom one down here. Okay, and we remember we covered adjacent pieces in the past, and it was also mentioned in section 9.3. Adjacent means next to, so we have the leg that is next to angle A, which is this bottom side AC. Now, let's not confuse that with the hypotenuse, because that's also adjacent to angle A, but we're not looking for the adjacent piece, we're looking for the adjacent leg. So we have here AC at the bottom. So it's going to be opposite over adjacent. Okay, so I'm going to abbreviate it that way. Now, if I was looking for the tangent of, say, angle B, then I would do this side over here, that opposite side over the adjacent leg, which is this green piece right here, right? That would be our our tangent of angle B. All right, so now let's try it out. If we're trying to find the tangent of certain angles, here we have a triangle STR, and we want to find the tangent of angle S and the tangent of angle R. Instructions say write each answer as a fraction and as a decimal rounded 4 places. All right, so then here what we're going to do is we're going to start with, okay, say angle R. Okay, so how do we find the tangent of angle R? Well, we said in the previous screen that to find the tangent, we need to set the opposite leg over the adjacent leg. Okay, so let's go ahead and try to find what that opposite leg is. Okay, so from this R, if I draw a line straight across, I'm going to get this value here, which is the opposite of angle R. So let's write it down here. Tangent of R is equal to 18 over, okay, so we put 18 again because it's the opposite of angle R. And then we're going to put that over the adjacent side of angle R. So remember, we're not using the hypotenuse, so not 82, but the adjacent side of angle R is 80. So we're going to do 18 over 80. Now, we can simplify this simply by dividing both numbers by 2. 18 divided by 2 is 9, and we have 40, and that's all we can get. So our answers here, it says that we want to give them both as a fraction and as a decimal rounded to 4 places. So here first, we're going to go ahead and put 9 over 40, and then if we type that into our calculator, we're going to get the value of 0.225. Okay, now that would be 9 divided by 40, but we want to make sure that it's 4 places. That's what the instructions tell us. So we only have 3 decimal places. So I'm going to go ahead and just add a 0, okay? Because if there's not enough, we're just going to add 0. Alrighty. All right, so let's go ahead and find the tangent of angle S. Okay, that's our second instructions here. So I'm going to go ahead and erase this work. Yeah, erase that piece there. All right, so now we're going to do the tangent of angle S. Okay, so we want to find the tangent of angle S. That's going to be equal to its opposite side over adjacent. Remember, we are not using the hypotenuse. So I'm just going to cross it out so I don't get confused. This time we have the opposite side being 80. So then the 80 is going to go on top in the numerator over the adjacent side, which is ST or 18. Okay, which again simplifies to 40, in this case on the numerator, over 9. So that's going to be tangent of S. 40 divided by 9, which we want as a decimal, okay, is going to be 4.4444444. Okay, and it'll keep on repeating. So, but we only want 4 decimal places. So 1, 2, 3, 4. And because the fifth one would have also been a 4, I'm going to go ahead and keep the fourth one as a 4. I'm not going to round it up. It's going to stay a 4 because it's less than 5. All right, and that is how you find the tangent ratio. All right, now here is something a little bit different. Here's what we're going to be doing on this one. We have the angle 32, we have 11 on one of the legs, and we have an x. Okay, so we're going to set this up to be able to find the value of our leg. Okay, in the previous one, we were finding the tangent of a certain corner, but in this case, we're looking for a leg. So how can we use the tangent ratio to figure out this value of x? All right, so I'm just going to go ahead and set this up with the information that I know. So I'm going to use the tangent, okay, but in this case, there's no angle labels, but there's a degree. You see how we have here, we have 32 degrees. Okay, so in the previous example, we had, say, angle R, okay, but we didn't know how many degrees R was. In this case, we do, so we're going to replace the the letter that we had in the previous example with the actual degree. Okay, so tangent of 32 degrees. That's going to be equal to our opposite side, 11, over our adjacent side, x. All right, so then we have tangent of 32 is equal to 11 over x. Now our x is on this side of the equation. So what we're going to be doing is we're going to have to put this over 1 so that we can cross multiply. Okay, so we can solve for x. So cross multiply. That's going to give me x times tangent 32 degrees is equal to 1 times 11, 11. Okay, now x is still not by itself, so I'm going to have to take one more step here. I'm going to just go ahead and remove the tangent of 32. Because it's being multiplied, I can get rid of it by dividing tangent 32 to both sides. All right, that eliminates that, giving me x is equal to 11 over tangent 32 degrees. All right, so now how do we actually do this if we don't know how to even calculate tangent 32? So what you're going to do is you're going to use a scientific calculator, which here I have linked the decimals.com /scientific. It'll take you to the scientific calculator. So I'm going to go ahead and open that. All right, so here's how you do this. So we have 11, we're going to divide by, and then you see on the left over here, we have sin, cos, tan. So we're actually going to select 10, and it's going to give you parentheses. Guess what you're going to put there? We're going to put our 32 degrees. Oops. 32. All right, so this is the answer that it gives us, but I want you guys to pay close attention to this, what I'm going to do right here. There's this little switch here that I'm switching, if you see here. One says rad, one says deg. This means radical, this means degrees, okay? The one we want to make sure that this little switch is on is the degree. Why? Because we're looking for 32 degrees. Okay, so we want to make sure that we keep that on because look, if you see the answer is changing from 16.64 to 17.60. So we want to make sure that that is at degrees, otherwise our answer is going to be wrong. The correct answer for this question is indeed 17.60. So I'm going to go back over here and I'm going to type x is equal to 17.60. Okay, and that is the value of our x value using tangent. All right, now how can we use special right triangles to find a tangent? Okay, so here what we're doing is we're finding the tangent of a 60-degree angle. Okay, so again, remember we can only use special right triangles, so we want to use a right triangle. So I'm going to go ahead and draw a right triangle, okay, kind of like a 60-degree. And if we recall from the previous sections, we have some special types of triangles. So if this is a right triangle, we want to look for the tangent of our 60-degree angle. Say this one's 60, then that means that this other one has to be 30. This is our 30, 60, 90 special right triangle. So if we recall, we remember, okay, let's go here. The value across from 30, so the opposite side of 30 is going to be w, which is the variable that we used. The side across from the 60 is w square root of 3. And then the side across from the hypotenuse was 2w. Okay, so let's recall that piece of information. But in this case, we want to use this information to find the tangent of 60 degrees. So remember, we want the tangent, and the tangent is equal to the opposite over the adjacent side. All right, so what I'm going to do to make my life a lot easier is I'm going to make w, in this case, equal to 1, just so I can solve this a lot quicker. Okay, so if w is 1, that becomes 1. This becomes 1 times the square root of 3, which is just the square root of 3. And then 2 times w, 2 times 1, is just equal to 2. All right, so I'm going to keep this just like that, just so I could find the tangent of 60 degrees. And this would work with any value of w. I could have made w 10 and changed these to 20, 10, and 10 square root of 3. But that would make my calculations just a little bit longer. So we're just going to keep it at 1. And we're going to use this information to find the value of tangent of 60. So let's write that over here. Tangent of 60 degrees. Okay, and we can also, I'm going to go back here to my calculator. And I'm just going to type in tangent 60. So that I know that this is what I'm supposed to get. Tan 60. I should be getting 1.732. But let's go ahead and show you how this actually works. So tangent 60 is equal to the square root of 3, which is the opposite. I'm going to put in the same color so we can see that. Square root of 3, that's the opposite of 60. And we're going to put that over the adjacent side. And the adjacent side of 60 would be this 1. And I'm going to go ahead and cross out the 2 because we're not using the hypotenuse. So again, the tangent of 60 would be the square root of 3 over 1, which is just the square root of 3. So let's go ahead and type that into our calculator. I'm going to put square root of 3. Now once I put the 3, it should give us 1.73. And if it does, okay, look, exactly. It's the same thing. Tangent of 60 is equal to the square root of 3, which is 1.732. So tangent 60 is approximately 1.732 or 1.73. All right. Okay. Please recall all of your special right triangles, as you will, might need to use some of those special rules to just figure out the tangents of certain special triangles. All right. So here what we're going to be doing is modeling with mathematics. We're going to be applying our tangent ratio to a real life problem to find the height of certain things. Here we're measuring the height of a spruce tree. If you stand 45 feet away from the base of the tree, so you are standing here, you measure the angle of elevation from the ground to the top of the tree. So you're at the bottom here, and you're measuring the angle to the top of the tree, and that angle is 59 degrees. What we're doing is we need to find the height of the tree to the nearest foot. Okay, so we're going to need a round by the end of this, but let's go ahead and set this up as a tangent ratio. So we know that the tangent of 59 degrees, right? Because that's the angle that we're given. So we have 59. Okay, what is the opposite of that? Remember, we have tangent is equal to the opposite over the adjacent. So the opposite side is h. So I'm just going to put h feet. Let's just put h for now. We'll put the units back at the end. Okay, so h over adjacent, which is 45. All right, so now here we're going to go ahead and do our cross multiplication, but first let's put this over 1 so that we're able to cross multiply. So h times 1 gives us h equals 45 times the tangent of 59 degrees. All right, now all we have to do is put this into our scientific calculator. So we're going to do back here 45, oops, new line, 45 times the tangent of 59. Okay, and that's what we get there, 74.89. So what we want to do here is we want to make sure that one, okay, our answer was in degrees. Notice how here, if I change it to rad, you see how now 45 times the tangent of 59 gives us negative 37. That doesn't make sense. So we want to make sure that it's always on degrees when we're using degrees as our tangent angle value. So our answer is 74.89. I'm going to go ahead and write that over here. Height equals 74.89. But our question says to find the height of the tree to the nearest foot. Okay, so we don't want this decimal value here. So we're going to have to round. So because we have an 8, let's go back. So because this is an 8, that's going to round this up to 75 feet. So that's the answer we're actually looking for. So this tree is approximately 75 feet tall. This concludes section 9.4, the tangent ratio. You should have learned how to find the tangent ratio, how to use the tangent ratio to find the leg length, and then anything else that you would have also learned. Please comment with any questions, comments, or concerns in the tile section down below. I hope you enjoyed. See you next time.